Hey, what's up, everybody? Welcome to our new way of doing notes, which is going to be me on a video talking to you. Okay? Now, what we're going to talk about today is we're going to talk about transformations of functions. And so I would like you guys to either jot down notes that you can turn in on a plain sheet of paper, or, we can print this out, or you can do it on Cami off of your computer. Okay? All right. So check this out, you guys. I have this big crazy function here. So the reason I know it's a function is it's basically like all being based off of y equals f of x. Okay? But now I'm going to do a bunch of things to f of x to kind of show you how that would change it when you start transforming it. Okay? So here we go. We're actually going to work our way backwards because I think that you guys already know this part and it makes it a little bit easier. Okay, here we go. This number at the end, the way this is going to transform our function is it's going to move it up or down. And it's pretty straightforward. Positive moves it up. Okay, negative moves it down. All right. So if I put a plus number on the end of it, like right on number 1, this is going to move it up 2. If I put a negative number on the end of it, this is going to move it down 4. Okay? So the number on the end will move it up or down. All right, great. In here, remember, you guys, that this moves it left or right. But the most important thing in here is it's actually the opposite of what it looks like. Okay, so let me show you a few examples. See how here, we'll do some of these in just a minute. All right, see how in here we are doing, that's inside of the function and it says -1. Well, that tells me I'm going to move it to the right 1. Okay, tells me I'll move it to the right 1. All right, now these numbers, A and B, okay, they can be a little bit tricky. They can be a little tricky. In fact, we're not going to have too many problems that have a number in here, although I will talk to you about how to do that. All right. And you guys, if there is a number in here, okay, here's what we're going to do. Actually, let's start with the outside first. Let's start with the outside first. All right. Check it out. This will flip it upside down. So it's going to flip it that way. Okay. Now, putting a negative on the inside, all right, will also flip it left to right. Okay, putting it on the inside will flip it left to right. All right. Let me show you a couple examples of this. Okay, so here we are on our favorite graphing utility, Desmos, right? And I just went ahead and graphed a parabola here for you guys. Okay, you'll notice it is shifted over right 1, down 4. You can see that right there. Now look at what happens when I put a negative in front of my parabola. Ooh, flips it upside down. Okay, you guys see that? So a negative in the front, it's going to be able to flip this upside down. Now, when I put a negative on the inside, look at what happens. Flips it left to right. Okay, I just put lots of negatives, make it go back and forth there. Alrighty, so that's how that's going to work. Okay, and then these numbers, here's what these numbers do. All right, this number, it kind of makes it skinnier or fatter, okay? Some books call it like a stretch or a shrink. All right, here's what I'm going to tell you. The easiest way to get it, if I have a number in front of the f of x, it's going to multiply all the y's by that number. Okay, it'll multiply all the y values by that number. If I have a number on the inside, now remember how this was so annoying right here, you guys, because left or right, it did the opposite. Same idea. Anything on the inside does the opposite. So instead of multiplying x by b, it actually does the opposite. It divides all the x's by that number. Okay? Seems a little bit weird, but I'll show you guys how it works. So this is like all our different transformations, all right? Okay, so let's look at the first question. So graphing using transformations, we don't really want to use like plotting points or whatever. We just want to do transformations. So step one is you identify the parent graph. All right. You guys remember my parent graph for a parabola x squared. And the points I'm going to use, I'm just going to remember these in my head. You guys do not have to write this down. Look, 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. Those are what we're going to remember of how we're going to graph it, okay? You just remember that in your head. Now, looking at this, how is this graph going to be transformed from the parent graph? Okay, so hopefully you guys all picked up 2. All right, so this means that my original graph, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4, each of these points are going to be moved up 2. Super fancy, so I can do it all in one thing. But we're just going to move each point up 2, which then moves the entire graph up 2, and I can graph this really easily. Okay? All right, nice. Let's go ahead and look at this next one. Now, what's the parent graph here? So the parent graph is absolute value of x. This is the parent graph, okay? All right. And you guys, what does the absolute value of x look like? Okay, so hopefully you all said, we know that the absolute value makes a V. Okay, it makes a V shape, all right? Okay, so now let's talk about how this is going to move, okay? You guys look at the inside number, look at the outside number. Remember, this is the opposite of what we think it is, all right? How is this graph going to be shifted from the parent graph? Okay, and hopefully you all chose that it's going to be shifted right 1, down 4. So if I go right 1, down 4, then I should be able to make my graph. Remember that this just makes like a perfect V going up 1 over 1. You can just put your arrows on the end. Okay? All right, nice. Now let's look at this next one. Now this is the first time that I have a number right here. Okay, so I'm going to kind of show you guys how this works. First thing I'm going to do is I'm going to remember that for a square root graph, okay, the numbers I like to use are 0, 0, 1, 1, and then you guys, what is the next number that we talked about that needs to go in this table? What number can I take the square root of? And hopefully you guys chose 4, 2. All right. So the square root of 4 is 2. So here's my point, 0, 0, 1, 1, 4, 2. I can kind of just like make that a little dotted or something. Okay, the next step, I'm going to say, how am I going to move this? Am I going to move this left, right, up, or down? All right, and this is going to move left 5. 2, 3, 4, 5. And I can move each point left 5, which basically just moves the whole thing up left 5. Now, you guys, I'm not quite done yet because I have this 2 that I need to worry about. Let me use a different color here. I got this 2, okay? And here's how this is going to work. All right, the y value here is 0, and guess what? 0 times 2 is still 0. The y value here is 1. 1 times 2, it's going to move up. The y value here is 2. 2 times 2, it's going to move to 4. And so it like stretches up like that. Do you guys see that? So it takes my like standard square root graph and it bends it up that way. Okay? So some of you that are like more visual learners, all right, let's go ahead and take a look real quick here. So if I have the graph of square root x, okay, there it is. And then the first transformation that I make to it is I go plus 5 on the inside, so that moves it left 5. Okay? Now let's compare that graph. I'm still going to do square root x plus 5, but let's compare that when I put a 2 in front, okay? So when I multiply by 2, see how this is my original graph, this blue one. And then the green one, it kind of goes up like that. So it stretches out because I'm multiplying the y values by 2. 1 goes to 2. This was up 2. That goes to 4. Okay. This was up 3. That goes to 6. It just doubles my y values. All right. Okay, cool. So that's how we'll do that one. Now the last one, a little tricky to determine the parent graph, but look at this. The parent graph is actually x to the third. Do you guys remember what we call that? What do we call x to the third? Okay, this is called a cubic. You guys remember it kind of makes a snake? I go like this, 0, 0. 1 to the third is 1, 2 to the third is 8, -1 is -1, -2 is -8. So this is my original cubic graph. Okay, I'm just going to dot it because I got to move this thing all over the place now. Okay, so here's what I'm going to do. I'm going to move it left 2, down 3, and the negative in front tells me to do what? That tells me I'm going to flip it upside down, okay? So I'm going to take this point, I'm going to move left 2, down 3, and upside down. Now, you guys, if I was just totally making a sketch, I would just go like that. And that's a decent sketch, all right? But if you wanted to do it like, I don't know, a little more accurate, remember it was like 0, 0, 1, 1, 2, 8. Okay, 0, 0, 1, 1. I'm just going down now. 2, 8. Goes a little bit off the graph, and then 1, 1 in the other direction, and 2, 8. All right. Okay, so let's take a look. Here's x to the third. All right. And so the first thing that happens is when I put, what was it? +2 on the inside, okay, +2, it shifts over there. When I put -3 on the outside, it goes down 3, and then check out what happens when I give it a negative. It flips it. All right, there you go. Okay, so we can do transformations using using squares, using absolute values, anything like that we've learned from our basic graphs, square roots, cubics, cube roots, all that sort of thing. All right. Okay, perfect. So we will go ahead and practice some of these in class. All right, good job, guys.